get started on reviewing here. So I'd already talked about just making sure if you're solving a system of equations, and that's kind of the whole purpose of this chapter, this unit, systems of equations, systems of inequalities, knowing what that is important. So again, two or more equations that have the same variables. Normally it's x and y, but it doesn't have to be. And then you're finding the ordered pair that satisfies all of the equations. So solving by graphing, I just have the steps summarized here. Again, you're graphing, if you look at example 1, both of these equations on the same coordinate plane. So to graph them, you want them in slope-intercept form, which again, slope-intercept form is what? Y equals mx plus b. And then you'll graph each equation on the same coordinate plane. Where they intersect is the solution. So you should write your solutions as an ordered pair. Even when we solve these tomorrow, when we're solving algebraically, because you solve for the variables separately, so you'll get x equals a number, y equals a number, but you should still write your solution as an ordered pair, since whether or not you're graphing, you're representing where the lines intersect. So if we were solving by graphing, if we look at example 1, and I want to graph this first equation, I first want to get it into slope-intercept form, so I'll solve it for y. So I'm just going to rewrite the equation over here. Okay, so I'll subtract 2x from both sides first. And have negative y equals negative 2x minus 1. And then either divide everything or multiply everything by negative 1. So I get y equals positive 2x and then plus 1. Is my equation. I know I didn't have you pick up rulers, so just do your best to draw your lines today. So if I was graphing this, start at 1 on the y-axis, and then my slope is 2, so going up to right 1, or down to left 1. I usually, with my first line, I'll definitely plot more points than are absolutely necessary to draw a line, because that way when I draw my second line, I can more easily see the point that they're going to match up on. But also, since I didn't pass out rulers, this makes it a little bit easier to draw your lines. You want to make sure they're very accurate, because if they're off by even a little bit, it can be hard to tell exactly where the lines might intersect. That's line 1, and then the second line, again, if I get it into slope-intercept form first, so I'll subtract 5x. So 2y equals negative 5x minus 16, and then divide everything by 2. So I'm leaving my slope as negative 5 over 2x. And then minus 16 divided by 2 is 8. So on the y-axis, start at negative 8. And then normally with negative 5 over 2, I would go down 5, right 2. But since that'll be off my graph, I'll go up 5 and then left 2. And then I can see already where they intersect. I'm going to make one more point here, though. All right, so solving the systems of equations, where they intersect is my solution. So that ordered pair is negative 2, negative 3. Bless you. Bless you. So just making sure you're actually writing the solution after you have the graph. Questions there? Okay, and then I have there, how would you check your solution? So how would you check to make sure that this is actually correct? Because a lot can go wrong when you're graphing. Logan? Yes, plug it back in to both and then make sure it works out in both. Or if you have more than 2 equations, you substitute it back into all of them. So if I were to do that, if I did it in 2x minus y equals -1, I'm not going to ask you to show me that you're checking it, but I'm just reminding you of this because when you're solving systems of equations, so between today and tomorrow, and even thinking ahead to a quiz or test on this, you can check your answers. You can know whether or not they're correct. So if I substitute -2 in for x and -3 in for y, I'd have 2 times -2 minus -3. And I would be checking to see, does that actually equal -1? So this would be -4. This here would change to +3. And -4 plus 3 is -1. So it works out in that equation. And then I also want to make sure that it would work out in the second equation. And notice I'm going back to the original equations, not the equations that I changed them to, not the slope-intercept forms. Again, in case I changed it incorrectly, that'd be something to look at. So I'd have 2 times -3 plus 5 times -2 equals -16. That's what I'm checking. So I'd have -6 plus -10, and that is -16. So it works out there. So say it didn't work out in one of them. My first thing to go back and check, I'd make sure if I had to rewrite the equations that I rewrote them correctly as far as I could tell. And then I'd make sure that I did graph them correctly. Those are the things I'd look back at. And if you are checking anything and it's not working out and you can't see why, just ask any practice that you're doing. Okay, questions there? All right, then one other thing we do with systems is classifying them by their number of solutions. And you may remember these terms from Algebra 1, but a system can be described as either consistent or inconsistent. And then if it's consistent, it's also characterized as either independent or dependent. So a system is consistent if it has at least one solution. So consistent means it has a solution. And then inconsistent means it has no solutions. So it is possible to not have a solution. And then if it does have a solution, so if it's consistent, if it has exactly one, it is independent. And if it has infinitely many or an infinite number of solutions, it's dependent. So your three types of solutions you're going to have, you're either going to have 2 lines that intersect and you'll have one solution where they intersect. And so that would be a consistent system and it's independent because there's exactly one solution. Or you can, when you say write the 2 lines in their slope-intercept form, if you notice, oh, their slope-intercept form is the same, they're the exact same line, then that means when you would graph the lines, they'd be right on top of one another and they intersect at every point on that line. And every line has infinitely many points on it. So then if they're the same line, there's infinitely many solutions. And you would write, if that was the case, you would write your solutions so that way you would say there's infinitely many if there wasn't just one solution. And so that's a consistent system. Since there is a solution, it's dependent since there's infinitely many. And then if the 2 lines never intersect, so they're parallel, it's inconsistent, there's no solution. And you would write no solution if you were solving it, or you could put the no solution empty set symbol. That would be fine. The only thing is one solution, you actually give the ordered pair. No solution, you write no solution or the empty set symbol. Infinitely many, you actually have to write the words infinitely many or there's an infinite number of solutions. Do not make the infinity symbol when it's infinitely many solutions. because that's saying infinity is the answer, which that's not true. Okay, so then the next one, I'm actually going to have you do. Actually, in your groups, you can look at 2 and 3, and we'll discuss 3. But in example 2, so it says to graph the system of equations, and don't just give the solution set. Describe it as being consistent and independent, consistent and dependent, or inconsistent. So just go ahead and graph that, and then which way would the solution set be described. And then you can look at 3 also. Look at that question because we'll discuss that as well. Okay, it looks like we're okay. But just double check. I wrote more up there than you need to write. But you should have gotten both equations. Both equations are y equals 2/5 x plus 2, so they're the same line. If you're solving by graphing, though, even if you see the equations are the same, to solve by graphing, you need a graph, so still make sure you graph the line. And then you don't actually have to write these, but I just wrote if this was like number 1 where it just asked you to solve, this is what you would write as your solution, either just infinitely many or infinitely many solutions. You would actually have to write that out if it just asked you to solve it. This one wanted you to write or to classify it, so it would be consistent and dependent. But this is how you would write it if it was like number 1 and just wanted the solution. There's infinitely many. Are there any questions? It looked like we were good for the most part on that one. Okay, and then number 3, it says without graphing, how would you be able to tell if a system of equations was inconsistent without graphing it? Anybody have an answer they'd like to share? Braxton? Okay, so the slope would have to be the same, but the y-intercept would have to be different. What was the first thing you said? Okay, in slope-intercept form. And then why would the slope have to be the same and the y-intercept different? Okay, and what type of lines are they? Parallel lines, yes. So to be inconsistent, I'm just trying to model to you like when you have, because you saw this on your test, but the things that all of us math teachers look for with a writing question, just so you're addressing everything. So let's see. I'll put inconsistent. You want to address that you know what inconsistent means. So inconsistent means the system has no solution and therefore the lines are parallel. And then I'll put meaning what Braxton said. The equations would have the same slope but different y-intercepts. If they had, say you just said they would have to have the same slope and didn't say the different y-intercepts, if they had the same y-intercept, then what would it be? Jasmine? Consistent and dependent, it would be what number 2 was. They'd be the exact same line. So having the different y-intercepts is important. So inconsistent means the system has no solution and therefore the lines are parallel, meaning the equations would have the same slope but different y-intercepts. Okay, so not looking for, like a lot of these questions, one sentence is fine, but just making sure you're fully answering the question, showing that the parts of the question you understand what that means, and then the proper math vocabulary. This is just, do you have complete sentences, capital letters at the beginning, periods at the end, that you're just writing a sentence or a paragraph if you have multiple. Questions there?